Hello. So screencast for lecture 1, which is about implementing controllers. So far we've been looking at MVC architectures and we've focused on the model part, so defining our data model, usually in terms of a UML class diagram, realizing that in a class structure that we're then turning into a database structure. And we were looking at the reason that that's a useful construct is rather than defining our database in terms of SQL and then trying to bind a data model or a class model onto that, we're generating the SQL from the class model and trying to get around this problem of database object mismatch. So instead of us having to write lots of code that materialize SQL into a model, it's all done for us behind the scenes, which makes our development cycles faster. This week we're going to look at controllers, and controllers are the kind of glue that binds your URLs together in the web space to this data model and any other functionality we want to execute. As I've said in class, I'm not intending for this to be a programming class, but it's very difficult to learn about web architectures without understanding the basic constructs that go behind it, so we're going to have to look at some of that. Do try and understand the underlying pattern though, because this MVC pattern is something that's going to crop up again and again in lots of different languages. So although we're choosing to try and illustrate the concepts using Groovy and Grails, the same patterns appear in PHP and in Ruby and in .NET. So try and absorb the generic parts and gloss over the deep specifics. I'd like you to get to grips with the overall concepts. And the other reason we're doing this, of course, is that later on we're going to need to look at some more web service ideas, in particular REST. And in order to do that, we need to have a basic grounding with MVC. After this week, you should be able to implement controllers, simple controllers of your own. Nothing too complicated, but at least be able to do a bit of processing. And the example which I set at the end of class was asking you to create a web app, which I think we started with a hello, which echoed back somebody's name, and then one which added two integers together and gave you the result. So just simple things, but that's what I'd like you to be able to do at the end of this week. If you can make sure you can do that ahead of next week, where we're going to look at some more complicated controllers, that would be useful. Before we get into the meat of it, although I don't particularly wish this to be a programming class, there are two structures which are very important for web architectures, maps and lists. And there's a nice Wikipedia page, obviously, on associative arrays. You can use this as a kind of launch pad for your own reading, rather than me pointing you at any specific book. So associative arrays or maps as an abstract data type are very important for web architectures, and the reason is, if I just go to google.com, so we're at the Google homepage here, and if I type in associative arrays, so I type in search, and eventually what happens is Google takes my input, passes it to a form. So let's have a quick, if we inspect this element. Somewhere here, there should be a form. Here's the form element, yeah, and we've got action is /search. So when we hit this search button, Google sends this value off to essentially to a controller in our current terminology, and that controller does some work and sends back a response, and the response it sends back is this URL, which somewhere in here we should see our, here we go, Q equals associative array. So that's what we typed into this box. Let me get rid of this. But Google's also sent through a load of other information which it uses behind the scenes. The reason that maps and lists are so very important for web architectures are that they give us a very loosely coupled way of storing this kind of information. So I need an interface in my controllers which is abstract enough and general enough to be able to deal with any web request, but also has the flexibility to deal with the fact that I could put ampersand Ian's parameter equals Fred on the end of this URL, and Google has passed that back to me. If you look at the end of the URL, it's not caused the search controller to blow up in any way, and indeed I might implement a feature a little bit later on that requires a new parameter. So we'd like our controller interfaces to be unified or uniform, so that anybody who's implementing a controller can understand the interface, but also be extensible enough and flexible enough to be able to deal with unknown web parameters. And that's why maps are so useful, because a map is an ideal structure for representing URL parameters in essence, and we're going to have to work with them quite closely as we're implementing controllers. So here's a diagram sort of representing an associative array item type. So here are the keys and here are the values. Again, as I said in class, just because we've got something that maps strings onto strings here, remember that the value doesn't have to be an atomic thing. It could be an associative array itself, or it could be a list, or it could be any one of a number of other abstract data types. So bear that in mind, it's useful. Now, because we're about implementing controllers, I wanted you to be familiar with this particular syntax. The syntax is similar across different languages, although Groovy does have its own sort of peculiarities. What we did in class was we looked at Groovy share, and I wanted you just to have some experience with the syntax. So we can declare a map by saying, the map we're going to work with in controllers is usually called params, and we declare an empty map by saying open square bracket colon close square bracket, and that's like a name and a value but without a name and a value, if you like. So that's declared me an empty map. I can initialize a map with some values. So what I could say is map describing Ian. So what I'm trying to do here is to follow some of the conventions that if you've ever read a book called Clean Code, which is definitely worth a read, there are some quite good conventions for describing variable names and things like that it's worth trying to follow, because it will improve your code. So I'm going to declare a map which describes me, and the first thing of course is I'm going to have a name property, the value of which is Ian, and let's have a teachers class parameter which is web architectures. So you can imagine, if you want to tie this back to web architectures, these could be parameters on a URL, ampersand name equals Ian, question mark name equals Ian, ampersand teachers class equals web architectures. So I have failed to declare my map there. Map describing Ian name. Oh look, you see, it's because I've used an equals there. Sorry. And I can extract values from that map by saying println just be lazy and not want to type all that in. So I'm going to access this map using the array accessor, which is the square bracket thing. Name. Okay, and it's printed in, which is what we expected. I can add things to the map. Now, this is one of the reasons that maps are quite useful. Supposing that I wanted to add something that said class times. Which classes do I teach and when? Obviously that's not a single value, so what I want to do is to add to this map a list. So let's just let's do that. Let's say map describing Ian. I'm going to set a new key, which is class times, and the value, rather than being a scalar value, is going to be a list, and I declare a list with square brackets, but it doesn't use the colon structure. So that's what we do. So map describe Ian class times equals square bracket a new list, and we'll say Monday at 4, comma Tuesday at 4. Okay. So what I'm doing is I'm setting a value called class times to a list that contains two elements, the first of which is Monday at 4, the second of which is Tuesday at 4. And if I now println, I'll just dump the whole map. You can see I've got my original name, teacher's class, and then class times, which is an array. And I could have made class times a map, or I could have made it a list of maps if I wanted to add more properties. So I don't want to get into this too much, just wanted to recap what we did in class. It's worth having a play with this because it's the syntax you're going to need to use quite a lot when we're doing our controllers. What I'm going to do then is I'm going to just stop this screencast now, because I'm going to do controllers proper next. So this will give you a nice, watch this, have a cup of tea, and then come back and look at part 2. Okay, so I will see you in a minute.